The first X-ray detection of the interstellar object 3 Atlas has just been reported by the Extend Soft X-ray Imaging Telescope aboard the Japan Aerospace Exploration EYES JAXA-10 ISM X-ray Imaging and Spectroscopy mission. The Extend consists of an X-ray telescope that focuses incident X-rays and an X-ray CCD camera that detects the signal and covers a wide field of view of 38.5 arc-minutes per side. The X-RISM satellite also includes the Resolve instrument, which performs high-resolution X-ray spectroscopy. The new X-ray image covers a projected square area of 3 million km per side around 3A Atlas and shows a faint emission glow extending up to 400,000 km from its core. Prior to this report, 3II Atlas had only been detected in the ultraviolet, visible, infrared, submillimeter, and radio bands. X-ray emission from solar system comets was first discovered in 1996 around Comet Hyakutake and subsequently confirmed in other comets. No X-rays had been previously detected in interstellar objects. Due to its large mass and extensive coma, Comet 3I Atlas represented an ideal target for X-ray observations. The X-RISM X-ray satellite conducted an opportunity observation of Comet 3I Atlas 1 month after its brightest perihelion phase on the 29th of October 2025, when it was hidden behind the Sun, invisible to Earth-based satellites. X-RISM can only observe the sky at a distance greater than 60 degrees from the Sun, and therefore its observation of 3I Atlas was scheduled accordingly from 2003, 120 UTC on November 26 to 2038 UTC on 28th of November 2025 with a total exposure time of 17 hours. 3I Atlas slowly drifted through the constellation Virgo during the observation. So, the satellite's altitude was adjusted 14 times every 3 hours to keep it near the center of Extend's field of view. A preliminary analysis of images centered on 3I Atlas revealed a faint X-ray glow extending over an angular scale of 5 arc-minutes corresponding to a separation of 400,000 km from 3I Atlas. This suggests that the bright X-ray halo is associated with the gas plume around 3I Atlas, which was detected by the Spheric Space Observatory and the Webb Space Telescope in August 2025. A possible natural origin for the reported signal is X-ray emission from the gas plume around 3 Atlas in its interaction with the solar wind. As charged particles from the wind exchange charge with particles from the gas cloud, this results in X-ray emission. Indeed, the Extend spectrum shows excess emission components associated with carbon, nitrogen, and oxygen in addition to background emission from the Milky Way or atmospheric emission from Earth. This is an important clue that the observed emission may indeed arise from charge exchange interactions between the gas surrounding 3 Atlas and the solar wind. This pioneering detection of X-rays from an interstellar object will certainly be followed by other research teams. It would be particularly interesting to verify whether there are other characteristics in the X-rays different from the expected signatures of charge exchange reactions with the solar wind. This discovery of X-ray emission adds a new layer of complexity to the mystery of 3 Atlas. While the charge exchange explanation with the solar wind offers a plausible natural mechanism, it requires the presence of significant amounts of gas around the object, something that contradicts previous attempts to classify it as a depleted or dry comet. The detection of carbon, nitrogen, and oxygen in sufficient quantities to produce detectable X-ray emission suggests an object much more active than conventional classifications would indicate. This is yet another piece in the growing puzzle of anomalies surrounding this interstellar visitor. First detection of X-rays from an interstellar object represents a milestone in astronomy. It not only expands our knowledge about the diversity of objects that visit our solar system, but also provides a new tool to study the composition and behavior of these mysterious cosmic travelers. The fact that 3I Atlas continues to reveal new surprises, have its unique visual structure to its energetic emissions, keeps alive the question about its true nature and origin. Here is the list of physical incompatibilities that make the comet explanation unsustainable when taken together, and each item will be explained below. Intrinsic X-ray emission, rigid frontal jet and anti-tail pointing toward the star, a weak coma and tail barely visible matter, anomalous metallic composition, very high nickel to iron ratio, strongly negative optical polarization, non-gravitational acceleration without sufficient visible cloud, minimal mass loss incompatible with such extensive jets, rotation and elongation signals that don't match a fractured ice nucleus, repeated orbital coincidences with passages by Mars, Venus, and Jupiter, unusual sequence of brightness variations and bluish tone, jets columnated for millions of kilometers, energy requirement incompatible with estimated nucleus size. First point, the detection of X-rays at Atlas's position. X-rays are not simply light reflected from our solar system's parent star. This is intrinsic energy emission. For a comet to produce X-rays consistently, it would have to be expelling enormous amounts of gases that, when interacting with stellar wind and particles, would generate such radiation exactly opposite of what we see in Atlas, which appears extremely dry with minimal activity. Second point, the composition. Studies indicate a nickel to iron ratio on the order of 10, 1 in the observed metallic fraction, something closer to industrial alloys than the composition of a typical cometary nucleus, which is dominated by volatiles and refractory grains with very different proportions. This chemical signature alone raises many red flags. Third point, the morphology. A well-defined antitail projected forward with columnated jets and a rigid frontal structure doesn't fit the model of diffuse ejection of volatile material. Natural jets tend to disperse and present similar colors and compositions when originating from the same source. In Atlas, we have jets with different tonalities, a clue of heterogeneity impossible to easily reconcile with a homogeneous ice nucleus. Fourth point, non-gravitational acceleration. Measurements indicate velocity changes that are not explained solely by gravitational attraction. In cometary models, non-gravitational accelerations are produced by sublimation of volatiles, creating thrust. But this requires mass loss and a visible debris cloud. In Atlas, we have acceleration without a cloud that justifies the magnitude of the change. That is, there's insufficient visible mass to explain the effect. Fifth point, the energy involved. Such extensive and columnated jets would imply mass flows and an energy absorption area that far exceed what a nucleus of Atlas's estimated size could support if it were just ice. In practical terms, the amount of material and ejection velocity observed would require energy sources or propulsion mechanisms that don't align with usual cometary physics. Important, a single isolated point can have alternative explanation. But when anomalies accumulate X-rays, excess nickel, frontal jets, negative polarization, unexplained acceleration, irregular photometric behavior, and orbital coincidences, the picture changes. The probability that all of this can be explained by a combination of ordinary natural causes rapidly declines. It's precisely the convergence of these signals that functions as scientific confirmation. Conservative scientists who initially dismissed radical hypotheses have begun to admit that the most likely explanation is no longer simply a comet. This is an opinion. It's a rational reaction to empirical observations.